Hello and welcome for our video today. In this video, we shall be discussing alkynes. In our previous videos, we discussed alkanes. We have also discussed alkenes. So today we are going to discuss a group of hydrocarbons called alkynes. Now, the simplest alkyne is called an ethyne. It has got 2 carbon atoms in the wrongest staging, as you can see. Now, all alkynes have got at least one triple bond. That is 3 bonds joining 2 carbon atoms. Like this one, you have 1, 2, 3. So these carbons will be left with only 2 electrons to bond to other atoms, in this case for hydrogen, as you can see. So this is an ethyne because we have 2 carbon atoms, so it is an eth. Eth means 2 carbon atom, and because it is an alkyne, the suffix now is an ine, like that. So this is open structure where we have now the condensed formula for the same molecule. And now the general formula for all alkynes is CnH2n minus 2. So the general formula for this ethyne here is, we have 2 carbons, so it will be 2 times 2, that is 4, minus 2. That means it is a 2. So the general formula for this molecule here is 2 carbon atoms. The molecular formula for this compound here is 2 carbon atoms and 2 hydrogen atoms, as you can see. So we have the open structure condensed formula, and then we have the molecular formula, as you can see. Now, if we add the number of carbon atoms in this molecule and also hydrogen atoms, like this, we add there, then we also add hydrogen atoms, like that. Now this molecule here is called it has got 1, 2, 3 carbon atoms in the longest carbon chain, so it is a prop. So we are going to replace this prefix here with a prop, like that. And because it has got a double bond in carbon number 1, then we say it is a propyne. So we can write the condensed formula for that molecule, which now becomes we have a C, like that. Then we have this CH3, and then we have that one, and a hydrogen. You can put a hydrogen atom there, as you can see. Not that one, this one. This group here, CH3 group here. Then we have this part here, and this hydrogen there. So now that one becomes a propyne. You can see the condensed formula and the open formula, like that. Now let us add another carbon atom to this molecule. If we add a carbon atom there now, then we have hydrogen atoms. Like this, we are going to add 2 hydrogen atoms, like that. Now our molecule now has got 4 carbon atoms in the longest chain, or the longest carbon chain having this triple bond here. So it is an alkyne, so we have the ine suffix, and then 4 we're going to have, it's going to be a but, like that. Now if you notice, we have to indicate the position of this triple bond here. Starting from this carbon here, we have 1, 2, it is in carbon number 2, and starting from this side, it is in carbon number 2. So either way, the triple bond occurs in carbon number 2. So we are going to put a 2 here, like that. So now the name of our molecule becomes a but-2-ine. Now let us add a CH2 group here for the condensed formula. So our condensed formula now becomes, you have a CH3 at that end. This is a CH3 group, like that. And then you have a CH2 group and this group here. So this becomes the condensed formula for but-2-ine, like that. Now if you continue on like that, let us add another carbon atom here. Suppose now this CH3 group was in carbon number 1, like this. We interchange such that now the triple bond comes to carbon number 1 like this. So this one becomes a CH2. We have this group here. So we have this CH3 group there, and this group here, which now becomes that one, and the hydrogen atom like that. Now 1, 2, 3, 4. We have 4 to the butte. Now this one is not the triple group is not in carbon number 2. It is in carbon number 1. We start from this side. It is in carbon number 1. Starting from this side is in carbon number 1, 2, 3. So we take carbon number 1. So the name of our molecule now becomes simply butane, like that. Now if we add one more, let us add another carbon atom here to this molecule, like that. So we have hydrogen there, hydrogen here. So for our condensed formula, we are also going to add a CH2 group, CH3 group, like that. So this molecule have got 1, 2, 3, 4, 5 is an open structure, and this 1, 2, 3, 4, 1, 2, 3, 4, 5. So this one now becomes a pent. Is a pent 5 carbon, meaning 5 carbon. The longest chain is having 5 carbon. Then the double bond here is in carbon, starting from this side is in carbon number 1, 2. So it is in carbon number 2. Starting from this side is carbon number 1, 2. So either way, the triple bond is in carbon number 2. So the name of our molecule there becomes a pentyne. Now, if you can look at the formula means that we have now we have 5 carbon atoms. So 5 carbon atoms. So 2 times 5 is 10 minus 2. That is 8. So we have C5. So this now becomes the molecular formula for this molecule here, according to our general formula for all alkynes. So if you want to confirm, we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. So now this continues on and on like that. If we have 6 carbon, it becomes a hexane or hex 2 in, and so on and so forth. Let us look for at one molecule here. So having 6 carbon atoms, and then we look at the name for our compound here. We add the number of carbon atoms now, and then we have added a CH2. So we are going to add a CH2 group here. So the longest carbon chain having a triple bond is this one here. So this is 1, 2, 3, 4, 5, 6. So our prefix becomes a hex. Hex means 6. Like this. This is our condensed formula. Now let us see the position of triple bond. 1, 2, 3. It is in carbon number 3. Starting from this 1, 2, 3, it is in carbon number 3. So now we replace these 2 here with the 3. So this molecule now is hex 3 in. Ine. As you can see, this is a triple bond which is in carbon number 3. And so on. If it is, we have 7 carbon atoms, we can have a heptine, and so on and so forth. The name of this molecule is the same for alkynes. Generally, we have the same way. Apart from now, we are dealing with a triple bond, which is also the functional group for all alkynes. Thank you very much for watching this video. We meet in the next video where we shall discuss a naming of branched alkynes. Remember to subscribe.